Thank you very much for coming, even on this beautiful sunny day. What are we doing in here? Oh, no, sorry, that's the wrong talk. That's the
Be sitting outside
that's the let's go for a fun run talk. Let's go for
the fog.
a lot of detail about the world of AI from a different angle. The angle is hardware, and our good friend Iain, who is a long-time supporter of ours, as he would be, he's an FBCS, has come here to tell us more from his knowledge and experience of working for over 15 years at Intel. And he's done so many different things at Intel. His current role is in marketing, where he's got a lead marketing role. But I've known him as being a CTO and various technical roles at Intel. I've only known him once he's been at Intel, so he's got a deep knowledge of the AI hardware world that we're in. And it's a world that's changing very fast, of course. We'll probably hear more about that during his talk. I would like to say that the room here is packed with people. Well, I'll say it. The room here is packed with people, but it's not really. What we have is a very select group of people here, and maybe that's the same in your living room or wherever you are. Do arm yourself with a drink, arm yourself with some good questions in terms of this subject, and let me hand over to Iain Beckingham.
Great, thanks, Dallin, and wonderful to be here. So I really appreciate you guys taking your time. I know it's a Monday evening, and you come down here, and here we are inside where it's sunny outside, and when in the front says we probably should be down the pub, but we're here. So hey ho. So let's make the most of it. Look, for those who have seen me present, I go anywhere. Right? You can ask me absolutely anything. I'm not going to say I'm an expert on everything AI, right? Or even hardware. Working at Intel, I do get exposed to a little bit of it now and again. But if you want, Intel's a lot in the news. You know, ask me anything about what's going on, what's the strategy, what's Pat doing. Happy to take anything.
Still making chips.
Yeah, we are making chips still. Yeah, that is a core part of our strategy. And actually, you know, Pat, for those who know Pat, so I've actually been around a little bit longer than 15 years, but we'll ignore that little slip, you know. So 28 years. When I first joined, we were doing Pentiums with MMX, right? And some of you, I'm looking at the audience here, probably weren't even born then. You might be. And we were doing video conferencing, and Pat was actually the GM of the unit to doing the video conferencing. Of course, today we take this stuff for granted. I mean, here we are, we're all zoomed in, right? It's just like, yeah, you know, but you know, at that time, we were doing this over a dial-up modem, right? So it's very different at the time. Okay, so without further ado, let's shift in. So where I was going to go, you know, everybody talks about AI, don't they? Right? Everywhere I go, everybody's like, oh yeah, AI, yeah, and AI, blah, blah, blah. And I'm like, wow, is this a load of hype? Well, what's the reality? I'd be really interested. I like to try and make this a little bit interactive. So I'd be really keen to hear from you guys. So what are you seeing out there as well? We'll look at a little bit of where the technologies are today, what Intel's doing from a hardware point of view. And then I was going to take it in a slightly random direction, which is looking at the sustainability side of AI as well. Because for me, that's actually quite an important. And then I wanted to go on, and this is just off the top of my head, or some of the research that I've done, looking at new technologies. We're going to take a look at 3 of them. Okay. Okay, not sure I've got all the answers here. I don't profess to have either. So questions at any time on absolutely anything. And if I can answer, I will. So, you know, as part of this, I went often like, gosh, you keep seeing it in the news, don't you? AI. So here you go. 3 snips straight out of the BBC content. It's a little bit old, these ones. And where I live is Guildford. So I'm like, man, Guildford Ice Rink is testing anti-skidding on an AI car. Well, would you believe it? Right? AI helping out time-strapped teachers, says the report. Even Peterborough Council. It's made the news, look. It's tracking fly tippers with AI cameras. AI is absolutely everywhere, isn't it? Thank goodness for AI. Well, actually, you know what? It's been around quite a long time, right? You know, it's been around years, in fact. We just didn't necessarily call it AI, or we did, and then it kind of went out of flavour. You remember some of the funding cycles, it definitely went out of flavour. And now, I think with Gen AI, it's caught the imagination of everybody, because everybody, how many people, let's just do a show of hands, how many people have gone in onto ChatGPT? Right, so that, I would say that's about 60% of people. How many people have done it to, you know, write their CV? There we go, there's a couple of hands up. But what about do their coursework? Nobody's, oh yeah, there we go. Somebody's admitting to doing their coursework. So, you know, it's really taken us, isn't it? And it's kind of it's an interesting one. Sorry, it starts off quite high level. We will get into some hardware in a bit, right? But it's almost disorientating. You go into the C-suite, you go and talk to the CIO or CTO, like, got to do AI. And you're like, oh, this problem we're going to solve. Well, yeah, the business problem, we've got to do AI. So it's, as the headline says, it is a little bit distracting, I think, for companies, right? Everybody's trying to figure this stuff out as to how do we use AI, even Intel, right? And I'll give you some examples of where we use it at Intel. So Intel manufactures silicon. Silicon comes in a wafer. We now, when that wafer goes through, it typically takes around 3 months to go through the whole manufacturing process. We want to know, is that wafer going to have a really good yield? Not good yield. So what do? Well, it's obvious, it's visual computing. So we take 2,000 photographs of all of those dies and compare them to what should be the high yield stuff. Fairly obvious, right? Fruit farmers do it with apples. Good apple, good apple, good apple, bad apple. Off it flies. Anyway, so what we see here is everybody's questioning the hype or reality. And actually, my customer base are exactly the same, to be fair. They're trying to figure out, how do they use it? What's the business impact that I can have with it? And, you know, if I'm honest, and I was actually at an IBM Cloud event last week, and they did a poll. And the poll was actually just kind of re-emphasize what I thought, which was everybody's looking at it, but they're kind of neutral. They don't really know what they're going to do with it. But they know that they think that they got to do something with it, right? And that's kind of where the audience was, right? Rightly or wrong. Now, clearly, and I will show you some examples of where companies are absolutely using this stuff and where it is making a difference. Intel did some stuff with the NHS. Again, it's a visual computing stuff, and I'll go and talk about one of our platforms called Getty in a bit, which looks at photographs of a nasogastro tube. So this is the tube that feeds you when you're in hospital. You don't want to have one of these things in, but sometimes you do. And ideally, you need to see if it's sat there correctly and it's in the right position. So again, you can train a model in order to do that. And then if it's an exception, you can then flag to the consultant, right? So when I look at AI, there's some really beautiful use cases where you're going, okay, that's making a difference. That's changing people's lives. That's, you know, solving some nice problems today. From a split point of view, well, you know what? There's a lot of money in this, a ton of money in it. And we're all after that money, aren't we? Including Intel. And of course, you're looking at AI and going, who do you think of when you think of AI hardware? In the audience?
Idiot.
NVIDIA. Anybody else?
Intel.
Oh, thanks, Alan. NVIDIA, absolutely correct, right? Anybody else? ARM, yeah.
Google TPU.
Google TPU, very good. And actually what you're seeing is, obviously NVIDIA, phenomenal company, right? You know, haven't they done well? And if you look at their stock valuation, oh my goodness, it's taken off. It's unbelievable. But you know, these things, I've been there and seen some of this. It comes in waves, doesn't it? Right? Maybe the bubble's about to burst because they did lose something like several hundred million off their stock valuation. Everybody's looking for a piece of this market. Intel, AMD, ARM. The hyperscalers are doing their own software, right? They're doing TPUs. Amazon's getting in on the act. Google's getting on the act. We all want that, and it's about owning ecosystem developers. Guess what? If you can trap them in, you know what? It becomes like, I say it, the IBM mainframe of yesteryear, right? Perfect example. So it's, for me, a bit where Intel's going, and Intel's maybe slightly different here, is we're all about open standards and an open architecture. Any questions so far? All good? Well, free to ask questions. By the way, I give swag away for questions.
Ian.
Yeah.
May I ask you a question? I'm not up to your swag, but so are we worried? Are you worried within Intel about all the base material being grabbed by China, the mountains that are being bought up and mined, and all the rest of it, which are being used?
So at Intel, we have a policy of we don't do conflict minerals, right? That's something, you know, ethically, we just don't go there. If we look at our, I'm not trying to greenwash you here, but if you look at all the renewable energy and stuff, it's like 93%. So we have a very good story, but I guess your point is, are we concerned about them doing, here's the thing, right? The whole point around what Pat is driving with IDM 2.0 is to balance the amount of semiconductors back into America and Europe. Anybody know how much of the semiconductors are manufactured in Taiwan?
90%.
It's about 80–90%, right? All of Taiwan, by the way, runs on diesel generators. Not exactly a eco-friendly statement. So part of the investments that Intel is doing is to invest into the States. And obviously, some of you will have heard of the CHIPS Act, right? It's a significant amount of money that goes into, hopefully, Intel. And then the EU has the CHIPS Act as well. So Intel is looking at a $100 billion investment into Ohio. We're looking at a $20 billion investment into Texas. We're looking to build a new fab in Germany. We're also looking to build an assembly and test plant. The chips go from Germany to Poland. Okay, these things are fairly significant dollar investments, right? $20 billion a fab, right? Fabrication plant. Okay, so then you would get the ability to have a made in Europe. Okay, and that becomes quite attractive because honestly, you're the CEO of EW. We can go, hey, we can manufacture your silicon Mr. VW or BMW or car manufacturer, and it's in Europe, and that's where you're manufacturing, from a supply chain resilience point of view, they are very interested in it. And of course, the geopolitical backdrop is, just have a look at what's in the press at the moment, rightly or wrongly, on South China Seas and, military drills off Taiwan and all of this kind of stuff. And people are really concerned around what the implications there are.
There is also it's a year or two since I read about this, but the fact that we have to maintain a facility that checks the hardware and firmware of critical kit coming into the country or being manufactured from chips abroad, because the chips may well be poisoned.
Yes, and this is something that actually Intel builds into its platform, which is like a firmware resilience. So, and this I think is an interesting point, because you're going to get to a stage which is, how do I know what server I have in the cloud and can I trust it, right? And so you end up building what's called like a trusted platform, and then you can do an attestation against various cloud providers to go, oh, yes, I am a trustworthy platform. This is the level of firmware. This is all the level of software that you have on your server, and therefore I am credible, right? If something breaks and you go, firmware level's wrong, then you can just not use that server. So that is something absolutely we have on the platform today.
I read it in the context of the mobile payment machines used for your credit and debit cards,
Yeah.
a restaurant or a shop or whatever. That was it, because all that firmware has to be checked.
Yes. Yeah. Any other questions? Did I answer it, Dallum? Around about May, maybe?
Well, I hope to hear more about that as we go through.
Okay. Marketing slide. Another marketing slide, really. But what we see here is AI across all of these different types of verticals, right? So people are looking at various different types of apps. So, finance, fraud detection. Now, for me, this is standard kind of what I would call classic AI, right? It's classic AI, ML, machine learning, right? There's nothing really that special around it. Some of the other stuff, teacher assistants, security, what else we got? Smart grid, incubation. Yes. There's some nice stuff there happening. But again, for me, I think what I see is a lot of the hype is around Gen AI, right? If you're a business, what you've got to figure out is, what's the value of having a unicorn riding a bike on the moon? Now, I'm being flippant, because if you're in the creative industry, actually, that's really quite useful, right? Because it's say you go, hey, draw me a picture of this, and you've got that. Make me a video of this that contains this, this, and this, and we can do that kind of stuff, right? For my general enterprise businesses, they're still trying to figure this one out a little bit. Now, some of the banks, let me stick with the finance example. Well, they're doing fraud detection today. They've been doing that a long time, right? And anti-money laundering. Morgan Stanley, have a call with their advisor. They will tell you that they're going to, this conversation is going to end up in the cloud. And what then happens is the conversation goes into a little bot, if you like, and it goes, right, here's the summary of your meeting. And guess what? Some of you will go, yes, we got that with Copilot and stuff like that. And yes, we use that at Intel as too. And it's not bad, right? It's quite a useful use case. And there is a comment in here. I put a slide, I meant to take it out. And it's basically, you've got to look at the cost of doing that, right? Because the cost of doing that may outrun the business case. And this is what people have got to start to think about. So I'll come back to that in a bit. Anyway, so lots of use cases, lots of different industries, and it's evolving. So, you know, I kind of been here a little bit, right? So 58% of CEOs from leading public companies actively investing in AI. Is this all the hype that we're creating as well? I don't know, right? You know, maybe Gartner's doing a very good job on creating a whole bunch of hype. It's the other interesting thing though, right? AI everywhere by 2026, 50% of edge deployments will involve AI, because everybody thinks about AI as these big, chunky GPUs that sit in a data center and consume a load of power, right? Well, that's partly true. If you go and talk to Microsoft and those guys and how much they're buying, right, it's phenomenal amounts, right? But the real use case for me around AI is going to be at the edge. And that's where you're probably not going to have you know, you're not going to be able to have loads of racks of GPUs and servers and stuff like that. So you've got to change the way that you do this kind of stuff. And people are looking at, everybody's heard of LLMs, right? Large language models. We're going to end up having more focused language models, right? So more domain specific stuff that comes along. Now, I didn't bring my new laptop here. It arrived Friday, and I was going to, but I thought, oh, I'm not going to risk it. That laptop is now what we call an AI PC. And you go, no, of course you would, Intel, you're going to say that, aren't you? Well, we just launched our Series 2, and it's codenamed Lunar Lake, right? So this has just come out. We only launched it like a week ago. And now what you have in the laptop that I didn't bring is you have an NPU built into it. Right? So low processing power, but able to do AI. So now all of a sudden, the landscape's changed, because guess what? I can put a small language model onto your PC and do stuff. Okay, that kind of becomes interesting, because now the compute landscape has changed. We didn't have that capability a year ago. By the end of next year, we'll have shipped 200 million of them. Right? There's quite a lot of devices out there that can now start to do AI. And so people, maybe, you know, if you think about AI as a film, right? We're not at the end of the film here. We're at the opening credits. And I think that's the way I kind of look at this AI journey that we're on. Now, some of the older members here will go, yeah, but we've been there and done that, Iain. It's been around for 30 years. You're absolutely right, right? But what's changed, and really specifically what changed it for me in 2015, 2016, is we started putting instruction sets into the CPUs that enabled you to do this kind of stuff, right? Where the machine could actually really compute the amount that's required to start to do RNNs and all of this kind of stuff, and natural language processing. Okay, any questions? Oh yeah, okay. Yeah.
One of the reasons I haven't put any AI on any of my devices is because I don't know what it's doing.
Yes.
Somebody tells me, oh, well, it's not taking all your data and digesting it somewhere else. And I say, you know that for a fact, do you? And they don't.
So this is one of the real concerns. I mean, there's quite a few concerns, right? And I will actually hit on some of the challenges and the concerns. And data privacy is clearly one of them, right? So certainly from an enterprise point of view, what you want to do, what you don't want to do is you don't want to go, right, we're going to take our data and we're going to put it into Copilot and then go, oh, actually, you know what? All our confidential information, it's just gone. It's public, right? There was a case where somebody has done that. So privacy and data security is a key thing. I mean, there's the whole ethics thing. I wasn't planning to go into the ethics, but that is something certainly from an enterprise point of view that is top of mind. But this kind of stuff, machine learning, we've been doing quite a reasonable amount of time. So machine learning, deep learning, a little bit newer, but I would say medical image diagnosis, gave you an example of that one. We also did, this was quite an interesting one. We worked with a company, gosh, what were they called? Health, something. Anyway, basically what it was a pill cap, right? And you swallowed the pill, went down your tract, popped out the other end, right? And what it had, it was cameras backwards and back on front, right? So take photos all the way down, and then you could do the inferencing on that to go, okay, here's the pictures of your gut. How does it look? Do you have any issues there? Dunham, you had a question or?
Online question.
Online question.
Yeah, Desperate asks, in addition to LLM, how does VLM come into the mix?
VLM being
I don't know, you'll have to clarify.
Maybe it's a very large model.
very large model.
Is it, Desmond?
It could be. And I will touch a little bit on very large models a little bit later from the sustainability aspect.
Visual language model?
Visual language model. Don't know. He knows more than me, clearly. He's your next presenter, Dallin. And then, so Gen AI, generation, marketing, copy, I'm trying to make digital assistants. And then the other thing that I often see people playing around with is it's something called RAG. People want to come across RAG? Yeah, one person. Okay, so retrieval augmented generation is what RAG is. And basically you use your own IP, if you like, or your own data to help train the model, right? So let me give you a practical example of where this gets used. Practical example of where this gets used at Intel is we have tons and tons of design docs. And gosh, we make it hard for us to find those design docs. It's absolutely incredible. So what we do is we put them all together on a RAG around it, chatbot on the top, and then go, can you tell me how many looms per panel has the new lunar lake? An answer. Now, the problem is it gets it wrong occasionally, which is kind of infuriating. So we're not quite there yet. Here's another example. Right, so if you're an IT help desk, I'm sure a few of you in IT, right? You've got this huge database of, oh, you know, here's how you solve this. If you've got a Lenovo X13, then, you know, this happens and you need to flash the BIOS and blah, 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 right? You've got that big database. That's a prime use case for RAG, right? You RAG, and think of RAG, right? Let me not call it RAG, because for me, it's slightly, it's super search. That's really all it's doing, right? But it's taking all of that data and it's putting it in so you can query it. It's not just text data, it might be graphical data, it might be pictures, right? All of this stuff now becomes like, wow, I can really mine the data. And this is something we did with one of the consulting groups where they have a whole bunch of IP that sits there, right? If you're a consultant, you've got all of this IP throughout, 30 years of material. And guess what? Now you can access it, but you can access it not in a look at all the, hey, do you remember that graph I did that talks about the S-curve? Or, oh yeah, this one here? Yeah, okay, so that's where it becomes a little bit of a game changer. AGI, anybody know what that is? It's where I'm out of a job. Okay, so we have a, yeah, come up and talk about it.
Right.
You want to talk about AGI?
No.
What is it?
I don't know much about it. I just know the acronym.
Is it adaptive graphics interface?
So AutoGI, isn't it?
Artificial General Intelligence.
Artificial general intelligence. Okay, so it's when you kind of all get to the stage where the machines are thinking before you and this kind of stuff, right? So it's fully automated. Good question. And have some swag. You like swag?
Flag.
Swag? Well, giveaways. My bag of giveaways. Nice slide, isn't it? So here's a lot of stuff that Intel does, right? Core Ultra is the new stuff that goes into the laptops, right? So Meteor Lake, Lunar Lake are the code names, right? But it's Core Ultra. So we rebranded it. Arc is graphics. This is an FPGA, Agilex. And then we've got our own accelerator. It's actually very good, right? It's called Gaudi. On our third iteration of it. This is just an accelerator that purely does AI. Only AI. And a lot of the GPUs actually out there just do high performance compute, well as this is really focused on just doing AI, right? And it's actually a very powerful product, right? Has a ton of tensor cores on it, has huge amounts of bandwidth going in, but it's actually it's faster than some of the NVIDIA stuff. It's actually cheaper than the NVIDIA stuff as well, which for a lot of customers, and I'm not trying to knock NVIDIA here, right? As I said, fantastic company. But people want a little bit of choice, and that's the differentiator here, which is around open ecosystem, open standards. The Goldman Sachs note. Yeah, the Goldman Sachs, I was listening to a podcast by Goldman Sachs, and basically they had done this Gen AI stuff, right? And they were like, oh, this is brilliant. You know, we can take our meeting minutes and condense them down. And then they kind of figured that out, which is, you know what, how much does this cost us? Cost them like 6 times the amount that they could have employed a human to do that for, right? And that was the, you know what, maybe this isn't all the hype that it's meant to be. So you've always got to look at the business case behind it. And I will show you on some of the sustainability angles as well, what the impact of running some of these large language models are, right? And it's huge. And I don't think we're thinking about it. Now, so where are we today? This is an example. I love this, aren't we? Gosh, we're bringing graphics cards to cars.
Why?
What do you think?
GPUs and.
Yeah.
Automated driving.
Automated driving. So if you look at the amount of compute power that's required for these cars, it's huge. I mean, yes, you could have your kids having a wonderful, almost Xbox experience in the back, or, you know, maybe they're watching Netflix on a big screen or something like that. That will be part of it as well, right? But a lot of it is to do with autonomous driving of the vehicle, and all the sensors in the system, and, you know, predicting what's going to happen. And, you know, because when you're a car, you're looking ahead on the road with all your LiDAR and your radar and your all of this kind of stuff going, okay, pedestrian crossing, somebody with a dog walking down the sidewalk, car, you know, very important thing. You're doing all of that analysis. So the amount of data that and compute power that is going into cars is huge. Right, we actually estimate something like by 2030, the high-end vehicles, 30% of it will be like compute of the bill of materials, right? And if you go to China, they are way ahead, way ahead of the European auto manufacturers, right? They're looking at stuff where you go, you know what, you don't have windows, you actually have you can choose your background, what you're looking at. If you want, oh, you want mountains? Yeah, we can put mountains up along the side. Oh, you want, no, seaside. Great, you can watch that as well, right? Endless possibilities.
Tesla does that now, though, doesn't it? I suppose that's Chinese tech, does it?
Yeah, I mean, that's a big market for them as well. It's a big market for everybody. They're all looking at this kind of stuff. But what you do see is you see China. Let me go back a bit, right? So a disruptor or an inflection point for the automotive industry for me was Tesla, right? Changed the game entirely. See, the Chinese market also changed the game, because they're not doing this like, gosh, you know, we we build a car, we prototype it, we make it out of plasticine. How long does that all take? You know, 4 or 5 years? No, these guys shrink it right down, spin it out really quickly. It's almost like, you know, continuous innovation can, you know, waddle.
But Tesla is China, isn't it? I didn't realise all their batteries are Chinese, BYD, Chinese.
BYD, yes.
Yeah, that's a Chinese group. So the whole of Tesla gigaplants are BYD.
Yep.
So that's all Chinese.
There you go.
And probably their, you know, their GPUs are probably Chinese as well. I think.
I can't remember who does Tesla. We actually have a spin-off company called Mobileye. Mobileye does a lot around autonomous driving vehicles. In fact, that we do some stuff in the don't know how true this or I'm not as up to date as I used to be with Mobileye because they've been spun off. But we used to put like cameras in the London buses. And what you're then able to do is map all the potholes, right? And now you can actually you've got a different type of business model because you can sell that data back to the councils who can go, oh, okay, that's quite useful now. I know that, I mean, they're everywhere, potholes really, but
Fixing it.
now they know where to fix them. And then you can look at other things like, you know, utility services and all of this kind of stuff. So there's a ton of use cases there.
Rails on trains and stuff like that.
Yes, yeah, exactly. Now, it used to be the domain of, you know, so we're only going back even 2 years here, right? 2 years. $10 million training for weeks on data center scale clusters on all, you know, right? Now we can do it in $100 worth. $100 in order to do that. You can do it on a Xeon processor, server or workstation, 25 megs of private data. So guess what? The prices are coming down. How are they coming down? Well, there's two angles here. Obviously, you know, Intel's doing a fantastic job and everybody's aware of Moore's law and doubling, blah, blah, blah. Well, theoretically, it's the transistor count doubles every 18 months.
Have they reached the limits of how much they can get on a chip?
No, not yet. People have always asked that question. We always think we can stretch it further. And if you look at the way this is going, we build transistors down to several atom widths now. You are pushing the boundaries of physics. We will end up going through every entry on the periodic table, looking for different types of weird elements that help us with, you know, reducing linkage current and stuff like that. We'll also look at different technologies that help you do packaging as well. So you can package upwards in 3D. We've got some wonderful stuff coming out on our latest node, which is 18A. And we've got a path forward to 14A and beyond, right? So we keep shrinking it down. I mean, everybody asks the question still, which is, how does it keep going? Well, it kind of does, right? But I've got some interesting data on, yeah, but what about the compute requirements for AI and how do they look? Because, you know, performance double every 18 months, yeah, okay. And, you know, we've got around it by adding cores, haven't we? Right? You know, we always used to have this monolithic die and now, you know, you buy a server. We got servers coming out with 144 cores in them. Right, ridiculous amount of cores. But you also need to think of the software paradigm models there as well. How do you take advantage of that?
It is 2 nanometers, isn't it? That's the sort of level of silicon. So they'll have to go from silicon to something else because it's just 2. That's why they're stacking 2 nanometer stacks.
That's why they stack,
That's
and why you do wacky things at the transistor level. Which I wasn't planning to go into here, but you're right. And then you look at other materials or other ways things of doing things. I'm going to talk about one slide and a couple of those.
Then they get unstable under 2 as well, like the solar flare will start interfering with the atomic structures. So that's why it's difficult when you get to that 2 nanometer level.
Yeah.
Or, So small and
Well, at the moment, it's accelerating beyond Moore's law because we've got chips now in production. Albeit small scale production, only thousands of chips at the moment, which are quantum computers.
Yeah.
And I'm quite interested whether Intel is investing in that area so the AI chips could be used as quantum and vice versa.
Yeah, we are investing in that area. That's one of the areas of research in the lab. So we have a quantum SDK as well. And I think we have a 49 qubit thing in the labs, right? It's not enough, but it's absolutely, I mean,
It's just very cold as well, isn't it?
Yeah.
Mm.
like almost 0 Kelvin and stuff, right? So yes, it is something that we're looking at, and you know, I look after a lot of the banks, and it's something they're extremely interested in, because the challenge you're going to have with quantum is if it does, I'm sure it will, we do get to quantum computing, it breaks all your compression algorithms, right? So they're part of the question they will have is, or encryption, right? How, if it breaks my encryption, then me as a bank, I'm exposed, and how do you get around that, right? And you know, essentially, you can probably double your key length and stuff like that, right? But that is something that is a major concern for financial institutions. So, in answer to your question, yes, it's something, and there is a quantum SDK that Intel has published, so you can kind of get a flavor. So software development kit, sorry. So you can kind of get a flavor for how quantum computing is going to work.
just to add to that, quantum chips are chunky as well. So we fabricate our own on site, the 200 nanometers.
Quantum chip I'm using at the moment is microscopic.
Well, yeah, but I mean, but it's when you look at this 200 nanometers so, with silicon. So it's not, you know, now we're at 2 nanometers. So it's 200. So it's a multi, you know.
Yeah, but the chip itself, you could put, shall we say,
Oh, yeah, yeah.
700 on a fingertip.
Yeah.
I think there's a talk here on Wednesday on quantum.
Yeah, I'm glad I'm not doing it, but no, but it's a super. I mean, it is actually on my list of, you know, where this stuff is going. So you're absolutely right to bring that up, right? Because, you know, if you are, well, I'll tell you what. I'll give you an anecdote. I used to cover cloud service providers. Now, this cloud service provider isn't Google or one of the big ones. It's a UK-based cloud service provider. £5 million, their electricity bill. That's what it was in 2022. 2023, £11 million. Like, bit of a problem for us.
We're not giving them the pensioners allowance then.
They went round and turned 2,000 devices off in order to save some money. Now, I'm not sure what those 2,000 devices did, but the point here is it's not about that, right? If you're Google, your number one concern at the moment, your electricity bill. Whether you can get enough electricity into your data centers as well, that's another thing, right? But it's a huge concern for people. So anything you can do to reduce your power consumption is going to be absolutely right, and that's the game changers that are going to happen.
It's the cost as well, isn't it? Not the amount, because it's all going up due to this green, all these green things coming out, aren't they? Because they have to add to the electricity bills, and the subsidies and so on.
How do you mean?
Green, all the green projects.
Oh, so what?
You say about 20% of the electricity bill is to cover all this green
investment.
Yeah.
Okay.
Yeah, Billy Band to come here and give a talk on it.
So there's another way of looking at it, which is, guess what? You just went back barely a year, right? So oh, this is US dates, right? So it's 1st of April. Look at the price. The token has come down. So it was $180 down to 75 cents, 240x cheaper. So the cost of AI is becoming, oh, you know what? We can access this stuff now. We can do this. That's kind of interesting. Now, I'm going to come back a little bit. I put this one in just to give you a little bit of a bit of background on Intel, quite honestly. But, you know, here we are in the 1980s. 1981, we actually came out, what IBM did with the MPC. In fact, it was, so I did work it out.
I remember that.
17th of August, I think it was. And it's DOS, compilers. IBM brought out OS2, for those who remember OS2, and Warp. Gosh, I'm showing my age here. And guess, oh yeah, this is where I joined Intel in the 1990s, where we go Intel MMX, multimedia extensions, SSC, AVX, advanced vector instructions. We've got something called a VTune profiler, right? For those who don't know what that is, think of this stuff as telemetry on your processor, right? So think of it as if you're a Formula One racing car, right? You've got all the telemetry coming off the car, you know, the braking into the corner, how much acceleration, how much G-forces, all of that. Guess what? You can do all of that on the CPU as well, right? So we can say, oh, code is rubbish. It's looping here, bound endlessly, and you know, you've got a cache miss over here, right? You need to go and optimize your code or vectorize it and stuff like that. So that's kind of what that does, right? And we built on this kind of stuff. And the point here really was we started OpenVINO is actually AI. It's visual computing, and it's quite well known because it does object recognition and all of this kind of stuff. It's open source, right? Again, back to the open source philosophy. And what you see here is we're actually thinking about AI coming into the architecture. And what we started to do was to put Intel instructions like VNNI, neural network instructions into the hardware. We've done AVX, various flavors of AVX, AVX 512, right, which are vector instructions. And then what you'll see in the latest gen server stuff is you'll have AMX, right, which are matrix instructions that go in. Now, for those who want to know more about that, in the backup part of the deck, it goes, I put some foils in there that go, this is how AMX works and TMULs and all of this kind of stuff. So you can have a look at how we've implemented it. But we've also implemented it in a way where the next gen of accelerator coming in, whatever that should be, we can actually incorporate it in, right? And that's important. Here's the other thing I think Intel does quite well. Some of you may disagree, but generally, you buy it on one generation, you expect it to work on all of the generations. And this is the point here, right? You know, Intel's been in this business a long time. You've got a big ecosystem out there that's grown up on x86. As I said, NVIDIA's done a very good job with CUDA, right? And the ecosystem there, right? And but the ecosystem is changing. And it's a lot about, it is about the hardware and the best you can get out of it, but it's also about the software models as well. The PyTorches, the TensorFlows, the Hugging Faces, for example. Yes.
To what extent are you using and or relying upon AI in the design and development effort?
We are doing that. And it is helping us, especially in validation. We think we're able to probably shave 4 to 6 weeks off the whole validation time by using AI, right? And there's other examples I can probably give you, but that's the one that springs to mind off the top of my head. So we are absolutely using it as part of our validation, but also our creativity as well, in order to bring products to market quicker. One of the things, you know, if you look at the life cycle, in some ways, we're a bit like that car manufacturer, aren't we? Right? The life cycle of project, you know, designing that server CPU, 4 years probably, about the normal life cycle. Well, you know what? We probably need to reduce that cadence and really start innovating quicker. So we've got to look at ways on how to do that faster. Oh, we've got a little video. So this is Getty, right? It's a little bit marketing, I know, but I apologize for that. But it enables me to have a swig of water. So I'll just play the video.
Coffee production is a $400 billion industry, with close to 40% of costs coming from labor management. Coffee growers continually make decisions about labor management based on manual assessment during harvesting. Specialized AI can help them assess the ripeness of their coffee fruits and make data-driven decisions for how many workers will be needed for the harvest at one time. But there is a problem. Most computer vision AI models fail from being overcomplex, expensive, and not allowing for cross-collaboration, forcing teams to work in silos. What if these farmers and agronomists had access to a simpler, more cost-effective AI development interface to participate in the process? Introducing Intel Getty platform, which makes computer vision AI development more accessible by enabling teams to easily build various types of computer vision models, from detection and classification to segmentation and anomaly detection. It also enables the team to work together, the domain experts, data scientists, machine learning professionals, and also developers, to avoid the siloed teams, to be more effective. In this specific use case, it makes sense to build an instant segmentation model to help farmers count their ripe fruits and predict their yield. Intel's Getty makes it easy for agronomists and data scientists to work together and identify ripe fruits starting with just 10 to 20 images, not the tens of thousands typically required to train AI models. Intel Getty is a breakthrough in the industry because you are creating computer vision workflow faster. In one single platform, you have all things together to create your prototype model. Domain experts, farmers, and agronomists can use smart annotation features for drawing boundaries and assigning labels to the fruits. The model starts training once the initial annotation required have been submitted. Once the model training is ready, the model could create the annotation by itself. Additionally, experts could use active learning and AI-assisted annotation features that help them provide feedback to the model's predictions to improve the model's quality. Following the quality criteria for each use case, Intel Getty offers a dashboard to help the team determine when the model is ready for deployment across compatible Intel hardware. The actionable insights from such a model can help coffee growers make decisions, plan their harvest, and ultimately improve their bottom line. All industries right now are using AI. Agriculture, healthcare, smart cities, manufacturing, all people need AI. With Intel Getty, you can empower your teams to solve computer vision AI across industries in a simpler, cost-effective, and more collaborative way, just like our agronomist friend.
So that's Getty, right? Getty takes it, I think, from you don't need to be a data scientist to actually I can annotate what I want on the model. Okay. So Royal Brompton Hospital here in London absolutely use this kind of stuff, right? If you're doing visual AI, this is brilliant because what you do is you take your people, let's say you're a pathologist or something, and you go, okay, cancer, 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 and you start training that model really quite quickly. And these people know what they're looking for, right? So they can help take that and train the model very quickly without having to have all of that background. So let's, oh dear.
Coffee production.
Right. Okay, so that's a little bit about AMX. I won't bore you with it. I wanted to just touch a little bit on this, right? Why is AI so challenging? And we talked on some of this kind of stuff here, right? Data security and privacy, that's a key one, especially if you're in a regulated industry, right? So if you're in healthcare, if you're in finance, this becomes quite an interesting dilemma for you almost, right? And the regulators need to kind of go, oh, how do we regulate for this? And some of the, honestly, some of the banks have probably had a bit of a yellow card from the regulator on some of this kind of stuff. the middle one, right? That's a tricky one as well. It's very easy to do proof of concepts or proof of value. You know, we can spin something up in a lab and getting it working, but how you roll it out across your institution is actually really quite tricky, right? And that's where a lot of projects fail. I mean, I see loads and loads of proof of concepts, and they're like, okay, how many have you taken into full deployment? It's like answers on a postcard. Costs I'll talk a little bit about because I wanted to as well. And then, gosh, I wasn't going to touch really on this one, the human impact, right? So, gosh, and how do you look at all the ethics, right? What the human impact is? How do you, if AI is giving you a, you know, let's say you've applied, the gentleman, he's just applied for a mortgage, and the computer says no. Well, you want to know why, right? Well, the AI said no. You need to be able to look back and have a look at the explainability on it as well.
The GDPR requires the lender to provide a second opinion in words of one syllable.
Whereas like, no.
Okay.
So before you move on from that,
Yeah.
way at the beginning, you said about looking at a chip, sorry, a wafer. Where it would take you 3 months to get through the whole system.
Yeah.
So coming back to this operationalization, that big long word, at some point you've got to say, hey, this wafer isn't going to work. We're going to take it out and so on. So that's actually, it's an awful lot riding on that. So you've got to decide at what point in your 3 months, your AI overrides the human operation, says, no, that isn't going to work.
Yeah,
First of all, did I understand you? Is it really 3 months?
yeah, so you know, when you take the silicon wafer in, typically it's about 3 months to get it out. Then you have to go to assembly and test. So you take the wafer, you split it up, you mount it on yeah, so it's about 3 months, yeah.
And your intelligent system can detect sooner than a human being that this is not a good wafer.
Yeah.
Wow.
Yeah.
Is a wafer and a chip the same thing?
A wafer is normally a silicon ingot, which is, well, they're normally about 300 mil. And then what you do is you etch the CPUs individually onto the wafer. So the silicon, so I don't have one in my bag, but essentially what you're going to do is you're going to have several hundred chips on that silicon round wafer. Yeah. And then the ones around the edge clearly ain't going to work because they're part chips, right? But you take the whole ones and then you will do some testing on them, right? And you do things like bin splits. So some of them you'll find will run at a higher frequency. Guess what? We can sell them for more money. Some of them are going to be, we can't run a higher frequency, but there's a market for that as well. And, you know, what Intel's really about is high volume manufacturing. How much, what's the best yield we can get out of those silicon things? I mean, it's phenomenally complicated when you go and look at this stuff in the fabs. And if you ever get a chance to go and have a look at a fab, we don't normally do tours where you put the bunny suits on, right? But it's like mind-blowing. These things they're like sizes of football fields, right? And we kind of clean the whole air every 8 seconds, right? We put the water back cleaner than when it came in, right? It's a phenomenal feat of engineering.
Do you have a different factory for each type of product?
We have, so it's, you have to like the node process. So if, for example, we're saying we're running on 7 nanometer, right? That will do all of our products that are on 7 nanometer. For the lower ones, like 18A, which is coming out, it will do every product as well, right? But it's whether with the design has been done to take into account that node transition. Okay. Typically, you know, when you go smaller, you're going to get more performance, you're going to get less power. Right? That's what we like about it.
So what kind of yields are you achieving at
We won't tell you that. That is very highly sensitive information.
What was the question?
The question was, and sorry, repeat the questions for the people on the bridge. What are the yields that we get out of a fab, right? And it's extremely, yeah. They won't let me know that. It's very classified. I mean, Pat did talk at a Deutsche Bank investor conference just a few weeks back. We are getting good yields on 18A, which is our next process node that we're going to bring online. But it's not in high volume manufacturing yet.
So is that 18 angstroms?
Yeah, 18 angstrom. Yeah.
Where are most of the factories? Are they in America?
The factories are all over. So we've got the nearest one to us is in Leaslip, near Dublin. And we've probably got, oh gosh, at least 3 fabs on that site now. Some of it will be older technology. Some of the older technology goes into like washing machines and traffic lights and what I would call embedded stuff. Some of the, latest and greatest node stuff will go on, PCs and servers and stuff like that, right? So Leaslip, we've got a couple of fabs in Ireland. No, Israel, sorry, Israel. We've got New Mexico, we have the States, Portland is D1X, which is the developmental fab.
That's Portland in Oregon.
Portland, Oregon, yeah. So that's a big site called Ronald Acres. Okay, I think they changed the name of that one. So, and then you've got assembly and test, right? And typically, where's that done? Costa Rica, right? So places like that. So, huge logistic efforts in moving all of these processes around. Can you imagine, and by the way, huge, put a load of these in a truck, right? The security that goes around that truck is immense, right? Because if we lose a truckload of processors, it's cost us several millions of dollars, right? Anyway, I digress. I answered the question.
Yes, I was just doing the sums. The green light, the wavelength is about 5,000 angstroms. You're down to 18.
Yeah, we're down to
Talking about
18.
X-ray technology.
Yeah, and we've got line of sight 30 to 14A. So 18A will come next year. Oh yeah, AI and sustainability. How are we doing? Oh God, we need to move a little bit quicker. So I'm going to move a little bit quicker through this one. Right, you guys can have the slides at the end. I need to take the speaker notes out and stuff like that. So headline, no surprise, Sherlock. Sustainability is a key thing for CIOs. Oh gosh, yes. Well, it is, and that's quite a good thing. And this is the slide I quite like, right? Because it really puts it into perspective on this one. So GPT-3, 175 billion parameters. So these are very large language models, right? Go for 280, 1,287 megawatts of, or megawatt hours, I should say, for training power consumption of this model. Now look at what the carbon impact on these things is, right? Here's a human life average for 1 year, 5 tons. A car, including fuel over the lifetime, 63 tons. And now people are beginning to wake up to what is the environmental impact of running AI and Gen AI? Because that's quite staggering, isn't it? Look at Google, 60% of their stuff, and do a lot of inference. Their energy consumption, 60% of it. It's just like, that's phenomenal. Now, I said about Google having a big power bill. They've got a really big power bill. So everybody's looking at this and going, gosh, we've got to do something here. So which is kind of slowly leading me on to, look, you can do stuff today, right? You can optimize your models, you can optimize software, you can optimize hardware, and you can do things like quantization, pruning and distillation. You can use some of the software optimizations that Intel's done, which really taps into some of those AMX, AVX instructions, right? We've done the hard work for you, right? So that's one way of doing it. The other way you can do it is to start thinking about green software and carbon aware software. This is going to be, you know, a little bit, it took me a bit of a while to get my head around, but I don't have a big head. So if you look at this kind of stuff, depending on your time of day, right? If you've got loads of solar and wind in the environment generating, oh, you want to run your code here, don't you? Because it has way less impact than if the sun stops shining or the wind goes away. I'm not reliant on this stuff. So people are going to have to start thinking about where they run their workloads. We see it already today, right? You know, I don't know who is with Octopus. Well, we're with Octopus. They write to us and they go, we finally got the smart meter installed. Dear Mr. Beckingham, you can have free electricity tomorrow from 1 to 2. We have enough green electricity. We have surplus of it, right? And you're like, oh, thank you very much. My user habits are changing. Yeah, absolutely everything in the house, 1 to 2 goes on. The dishwasher, the washing machine, the tumble dryer. You know, I charge all my devices all up. Thank you, Octopus. Right? Well, it's kind of no different really to this kind of stuff. Anyway, code improvements. You can read that kind of stuff. So one of the things that you really want to do though is also to think about what are you deploying it on? What's the right hardware? I mean, let's face it, you know, it's a little bit like a car, isn't it? Right? You know, I've got a family, they treat it like it's a bin. You know, I don't go around in a Porsche, right? It goes around in an old 11-year-old SUV thing, probably not the most environmentally thing, but it does what I want it to do for the purpose that I have. Dalim, on the other hand, right? And his wife living the life of luxury, goes around in his 2-seater Ferrari. He doesn't say that, does he? But, you know, perfect for him. Other people are like, you know what, I live in London. I can't afford a Ferrari, can't even afford a car. I'll rent a car. Okay, so there's a, you know, depending on your usage. So you got a tube pass, have you?
Yeah, free.
Oh, perfect. Free pass.
Pensioner.
So the other thing you can do here is you can do liquid cooling as well. So, you know, I'm sure you're aware of cold plate cooling where you just put cold liquids in that passes over the CPU, but we actually have down in Swindon, we actually have full immersion tank cooling where you put this stuff in some liquid, it massively cools it. Now, if you think around, if people are familiar with PUE, which is like a measure of how efficient the data centers are, you know, average in China is about 1.5. With immersion cooling, you'll get it down to about 102, right? So it's quite a game changer in the amount of cooling that can happen and, you know, all of that kind of stuff. So, yeah, it's kind of an interesting one. I mean, it's not for everybody, because if you can imagine all of that liquid on a data center floor becomes very heavy, right? So you might have to reinforce your floor. But anyway, there's things there, right? There's also two-sided business models where you take your heat off your data center and you warm a swimming pool or whatever. I've got 5 minutes. The bit of a marketing slide. So Gaudi, very good for training and influence. Xeon, actually, we've got a load of people doing just influence on Xeon. You don't need to actually buy all these GPUs. This is what people just don't get, right? You can just do this kind of stuff on general compute hardware. Nice thing with general compute hardware is if you want to do something different, you just can. You can use it for different purposes. right? And so actually you get a far better return on investment. And Core Ultra is the laptop stuff. So this is where we're putting AI into the laptop. So you're going to have the ability to do LLMs or small LLMs into the laptop. So think of it as, you know, obviously people are aware with Copilot, we're aware with the black background blurring and all of this kind of stuff, but you know, you can start tracking people's eyes and all of this kind of stuff, right? So some nice stuff coming there. Right, let 5 minutes to do this. Okay, so here's a comparison, right? State of the art, cockatiel parrot, brain power, 50 milliwatts, right? 2.2 grams, can navigate and learn completely brand new environments at 22 miles an hour. It can even speak English words. And it can learn to manipulate cups for drinking. On the other hand, here we have an autonomous drone, which has 18,000 milliwatts of power, 40 grams. It could be pre-trained to fly between a couple of points, or even like a little circuit or something like that, and it can't really learn anything online. My point here is the brain remains unrivaled against computing devices today. I wanted to put this one up, right? This also goes back in time to 1960, right? And here we have, you know, 2-year doubling of Moore's law. We got some other stuff coming in with AI and all of this kind of ResNets and neural machine translation, all of this kind of stuff. And if you look at where this stuff is going, right, this wasn't, this is an open AI source, right? 300,000x increase required training computation over 6 years versus 8x provided by Moore's law. So there's the challenge for us, right? Gosh, there's a ton of compute that is going to be required here. We're not on a real trajectory to close the gap with nature, right? So we're all familiar with standard compute, right? If X, then blur. Parallel computing, okay, I think we're familiar with that. This is something that Intel's working on, which is neuromorphic computing. So this is like simulating the brain, simulating neurons, right? So you have the ability to learn on the fly, like you would as a brain, right? You have the ability to do spike events, synchronous spike events. So again, it changes the complete model. This is, we're on our second iteration. This is in the labs, right? It's not, we're not selling it yet, I would say.
Any difference in your computing with the FPGA, field programmable chips?
Yeah.
Is the same thing or different?
Slightly different. I would say that's more in the parallel universe of stuff, right?
So where's most of the research going on? Is it in one location or spread? You're researching all this stuff, your methods. And...
I would say it's probably, you know, we have strong linkage with a lot of the universities. But a lot of this is probably done in the States, but you know, we've done some stuff here in the UK as well. So yeah. Tell you what, let me come back to this. Let's have a look at what it does well, right? And hopefully I've got some animations here as well. Right, so this is a robotic arm control, 40x lower power, 50% faster than a GPU, right? This is Sudoku, it's solving Sudoku, right? So we actually think with neuromorphic, we can do it way quicker and tons less on the power consumption as well, right? And, you know, scene understanding, object recognition, tracking, learning, all of this kind of stuff. You can imagine this going into, you know, manufacturing plants and stuff like that, right? Guess what? 100x lower power consumption versus a GPU. So this is, you know, just our second stage iteration on Loihi, but we think it's definitely got some use cases out there. Now, there's a ton of other technologies that people are looking at, right? And actually, I have one more slide on this one. Oh, no. Okay. So, by the way, I stole this, hopefully with pride, from a guy called Andrew Floss, who's also an FBCS, and he is at Bear Computing. And I'm going to talk a little bit about Bear in a little bit. And what he's put this together, and it was on LinkedIn, so, you know, it's public. You can see some of the stuff that we've talked around, you know, so we've talked on accelerators. This is packaging, memory. Glass substrate is something that Intel is absolutely working on. We've demonstrated glass substrate as well. Definitely doing chiplets. Photonics, where his company is in is reversible computing, right? And his neuromorphic, right? And we've got quantum at the top here. Right? I'm just like, I can't pick all of these things, right? So I'm just going to pick a couple of them. So we talked around a little bit on neuromorphic computing. I wanted, so Intel has a deep tech startup program called Ignite. And I was really fortunate enough to be the mentor, the lead mentor for Lumai, right? Now, Lumai, gosh, if these guys get it right, it's a complete game changer, because what they're doing is they're looking to do matrix multiplications in light. I'm like, wow, how do you do that? Now, to be fair, I still don't know, right? Because, you know, the guys there are just phenomenal. They are PhDs from Oxford, so they've spent their time doing this. So, but look at what they're trying to do. They use light in free space to perform matrix operations, which is basically what AI is, okay? When you do it in light, you get rid of all of those power things, right? So people are going, oh, you know what? I really like this. Oh, you know what? It's quick too. Oh, okay. So they've got a roadmap to 50x the performance, right? With less power. I'm like, gosh, this could be a real game changer. So fantastic, you know, startup based in the UK, right? They were in the Oxford Business Park. And you know, if anybody's interested, I can hook you up with those guys. There's a great guy, Phil Burr, who's head of product there. You know, it's early days, right? But it is going well. And then I wanted, this is, I think, almost the last slide, right? Because I'm conscious of the time we've run over.
It's okay. You can run on for
okay. So these guys, so we move from O to C. Cambridge, right? Cambridge is an allowed word in my household. Oh, you know, I'm booted out the door if I say that word. Reversible computing. Ooh. So when you do a compute, right, transistor goes through power, heat. Anybody know what adiabatic is?
Yes, no, it's cooling things, isn't it? It's Arabic, where water goes across the sheet.
Keep the entropy of the system. You don't lose the heat, right? So what they think they can do is you compute, you can almost reverse it, right? It's a bit beyond me. This is why Hannah, who's the CTO, has a PhD in this subject. I've got to say, Rodolfo, he's probably hired the brightest minds. Reversible computing isn't necessarily a new concept. It has been around. It's very much been in academia, right? But again, if they can do what they think they can do, and there's a talk, I should have put the link on, but if you go on LinkedIn, you can find a talk on what this is and what they aim to do, right? It could be a complete game changer for the industry. They think they can do this on CMOS today, right? So I just wanted to chuck up a couple of examples of some of the stuff that is going on out there. I'm sure the audience, you're probably more aware of some of this stuff than me, right? More knowledgeable than me as well. Anyway, I think. Oh, yeah, that was me done. So, thank you so much. Interesting. And I think, oh, Alan's coming up.
Oh, I hear bells. Great. Well, let's treat this as part 5 of X, because this is an ongoing story that is going to continue, especially in this decade. But when I say that, we are part of that story, and we are helping to drive it on. In terms of where we go next, I don't know. You know what the future holds in terms of this world of ever more powerful computing spreading throughout all of our business and home life areas? If you do, come and see me. I want to know more. Meanwhile, thank you very much, Iain. Please join me in thanking Iain.
Okay.